The generative AI revolution is here. Extremely powerful AIs that can create human-level text, imagery, and video are poised to shake up a wide range of industries. By typing in just a sentence or two, it's trivial to create professional quality creative work, powered by AI systems that are running on high-end graphics cards. But how could this affect video games? Big budget titles are brutally labor intensive, requiring hundreds of people to work in often challenging conditions over the span of years to bring games over the finish line. By utilizing these technologies, perhaps those demands could be lessened. And there are some intriguing user-side applications as well. So today we'll be looking at AI image generation, video generation, and text generation, and applying them to common game workloads. Is AI-generated content here to stay? AI image generation has become extremely powerful, and it has a wide range of uses in gaming applications. I actually produced an entire video 6 months ago on the potential for image generation, and many of the uses that I hypothesized back then are being used today. But first, let's take a look at the quality of the actual image generation process, because the quality increase has been remarkable. I used the exact same prompt for both the left and right images, just with different versions of the Midjourney image generation tech at different time periods. My initial generations seemed decent at the time and did feature in my earlier video, but the recently released Midjourney V5 is capable of so much more. The increase in quality is frankly sort of outrageous. We've gone from vague, artifact-ridden images to coherent, professional quality pictures with zero visible flaws. I'm highlighting Midjourney in particular here because it has experienced a very dramatic improvement, but other imaging applications can offer similar quality levels with just a bit more effort. With newer image generators, producing production quality work is very possible, even with simple prompts. A bit of quick photoshopping, and it's easy to bash together some AI-created 2D work to show you what this might look like in an actual game. I did have a little bit of fun with these, but I think you get the idea. It took me mere minutes to generate the images I needed, and not much longer to composite them all together with a bit of work in an image editor. I personally have done quite a bit of digital illustration and design work in the past, but this speed of production is well outside of any human capabilities. There are new prompting techniques and image analysis tools to keep visual styles consistent as well across image generations. Image generation is particularly powerful for iterating on existing work. As an example, the recent Persona 3 portable remaster has extremely ugly AI upscaled background art, but we can easily replace it with higher quality work by using image-to-image based prompting features alongside our regular text input. The original artwork essentially provides the framework for the new compositions, with the updated work slotting in neatly. I was quite frankly a little bit repulsed by the quality of the AI upscales in this title, but the new AI created work feels tonally and compositionally appropriate, even though I really didn't put in too much effort here. I think this is a fantastic option for remastering efforts that need to rework low-res and low-quality 2D art for modern platforms. But if you have to actually build larger contiguous work out of AI imagery, you may want more control and more resolution to work with. Using Stable Diffusion, it's pretty easy to simply outpaint detail between different key assets. We can simply place individual pieces of AI-created work as well, and then use AI to generate context-appropriate artwork to bridge the gaps. It's sort of like content-aware fill in Photoshop, except that this is quite a bit more powerful. At the moment, this does work pretty well, but with upcoming versions of Stable Diffusion, it should be even more capable. Plus, if you need to correct any part of an AI generation, you can essentially do the opposite, which is called inpainting, to fix the problem. We can easily expand to the world of 3D as well. Here, we simply need to create some shots of our object from a few different angles, and then paint those details onto a 3D model. I'm not particularly seasoned here, but this seems fairly usable as long as you restrain yourself a bit and use it more for stationary objects or peripheral characters. For creating 2D assets, I suspect that most people will have the best luck using Midjourney V5 as a starting point, as it produces the highest quality artwork out of the box, possibly moving on to Stable Diffusion if they need certain advanced features like inpainting or need custom model training. As a final note, the highest-end image generators, particularly Midjourney V5, are perfectly capable of creating photograph-quality images. Just a couple keywords or a sentence, and you can create incredibly realistic imagery that often passes as a genuine article. Even prior AI bugbears, like hands, can come out perfectly fine. This means that producing finely detailed, realistic textures out of a generator is both reasonable and achievable, which is something that really wasn't true until quite recently. Relative to what we had 6 months ago, there are a few key improvements. The quality of the images has obviously increased, but the other upgrades are equally as impactful. You can actually get pretty good results out of the image generators by simply using natural language, so there's no real need for the awkward keyword-based prompt engineering that was used in the past. I actually created most of the prompts in this video by asking GPT-4 to write them for me, either with keywords or full sentences, which worked out very well. The ecosystem around the generators has improved a lot. There are so many great Stable Diffusion GUIs, including excellent web services like Leonardo.ai, and image generators have been integrated into common applications used in game development. The general understanding of image generators and how to best implement them has also advanced considerably. So image generation is a lot more flexible, fast, and high fidelity than it was a few months ago, and the results are tremendously impressive. Video generation is very immature at the moment, but it is extremely promising. So I'm going to take some short videos of Doom 2016 and Quake gameplay and use a few different methods to see just how far we can push graphic stylization using video generation techniques. The first thing that I decided to try was to just take a look at Stable Diffusion. After all, a video is just a string of images, right? Unfortunately, by default, Stable Diffusion's image-to-image features can sort of break down when you need it to very closely mimic the original work. I can easily get interesting results out of it, but only if I'm willing to sacrifice much of the structure of the original gameplay footage, which isn't really what we're after here. There are some interesting results that people have achieved with Temporal Net, which is basically a custom Stable Diffusion model that uses frames of previously generated output to achieve a more temporally stable result for video content. This is definitely the right way to go, though I'm not sure that Stable Diffusion itself is the best platform for this kind of work. But there is at least one good alternative. Runway has just begun to offer a video generation service for the public, called Gen 1 Video to Video, that basically stylizes video clips that you feed it. It's sort of like a style transfer technique like EB Synth, but it's more comprehensive than anything that I've used in the past. It is pretty amusing seeing Doom rendered in these sorts of abstract artistic styles. It actually looks a lot like old rotoscoped or painted over video, albeit without any manual labor involved, and with greater detail and complexity. We can choose from a few artistic presets here, or we can simply write in our own as we see fit. The Runway solution is the first that I've seen that combines meaningful footage transformation alongside that crucial temporal stability that is tough to achieve with Stable Diffusion-based methods. And their demos from their currently private Gen 2 video generation systems look even more impressive. There are also pure text-to-video approaches that are sort of crude, but are already making some pretty substantial strides. Based on how diffusion deep learning models work, I'd expect these to scale pretty nicely with increased model complexity and fine-tuning. For instance, if you look at the sort of improvements that Midjourney has made over the past 14 months or so, going from extremely crude and abstract images to near photographic quality, some significant improvement in video generation over the short term is probably to be expected. For most gaming applications, you'd really want to run this in real time, of course, which poses a large hurdle given the compute time needed for individual frames. But the frame-to-frame consistency and tolerance for graphical errors inherent in real-time rendering opens the door to a lot of tricks, temporal solutions like reprojection, and dynamically scaling resolution to claw back performance. And the models as they currently exist are probably bloated and could be pruned much further to run faster. Plus, many PC gamers are already packing very good GPUs with lots of low precision performance and gobs of VRAM that should be well suited to these kinds of workloads. It is a big ask, but I wouldn't be surprised to see optimizations that could take this kind of technology to work in real time in the next few years. Text generation, put broadly, is probably the most headline-grabbing use for AI at the moment. ChatGPT and Bing have really caught people's attention in recent months, with human-quality text output and the appearance of complex reasoning abilities, the kinds of breakthroughs we've simply never seen from language processing systems in the past. In broad strokes, these AI models are trained just like the image generation models. A basic architecture for processing content is combined with a lengthy GPU-driven training process where the AI learns from hundreds of gigabytes of text. It's essentially a statistical process that produces a package of billions of model parameters that can then be sampled to generate new text based on a given input. On top of that, there's a fine-tuning process, often referred to as reinforcement learning with human feedback, to get the model to produce results that are more in line with what humans like. OpenAI has the leading language model in the field at the moment, called GPT-4, which was released a few weeks ago. Fundamentally, GPT-4 seems capable of complex inference and has good memory of the vast sums of information in its training data set. That means it exhibits human-like abilities across a range of text-driven cognitive tasks. It's less generally capable than a smart human, but in a lot of respects, it's in the same ballpark. It's a very good programming tool or general-purpose writing tool, for instance. If you can apply GPT-4 effectively to a common workload, chances are that you will see a substantial productivity boost. It's obviously a tool that individual programmers and writers are capable of exploiting, but there are efforts across the industry to introduce language model-based tools for common workloads. When it comes to these kinds of large language models, it's very challenging to enumerate all of their potential uses, because they have a sort of general capability in most tasks. It basically turns out that combining massive pools of data with powerful GPU clusters alongside the advent of a few deep learning modeling innovations, specifically the transformer model architecture, and you can build AI models that are truly remarkable. Plus, we can use AI-powered text-to-voice to actually bring our text creations, AI-powered or otherwise, to life. And you can submit your own vocal samples as well, and have the technology attempt to recreate your voice.
It doesn't do a great job in my case, but the technology is capable of emulating human vocal characteristics quite nicely, producing fairly natural speech with few synthetic markers.
I've had an interest in generative AI technologies for years, but back when I was looking at deep dream images or seeing early samples of GPT-1, I had no grasp that things would progress as far as they have. It took my own personal extensive use of GPT-3 starting a couple of years ago to convince me that generative AI would become very useful in the near term. And GPT-4 and Midjourney v5 are exactly those products. They're generative AIs that are finally good enough to have broad applications. And that applies to games about as much as any other field. Video games are enormously labor-intensive to produce, with high-end titles demanding years of work from hundreds of people. Technologies that can reduce that effort should be celebrated as they enable a much broader scope of accomplishment with the same human workload. For smaller developers in particular, it could be game-changing stuff. You may not be able to afford a large art department, but that doesn't mean that your game has to look low budget. It also has the potential to reshape what user-generated content looks like in video games. Imagine a title where you could create your own game avatar, creating a character through a machine learning process instead of through on-screen sliders. Or a game where you could type in your own dialogue and have NPCs realistically respond. Titles like AI Dungeon and early experimental efforts like Facade have pioneered some of these techniques, but recent technical advancements will make them practical for many more types of titles. Controversies do surround the various uses of generative AI. Like all machine learning applications, generative AI tech depends on training on large datasets, which in some cases can contain copyrighted information. The productivity gains that many anticipate could dislocate a lot of people from their current jobs, particularly for those in white-collar professions. And AI systems can be used for very exploitative purposes if sufficient guardrails aren't in place. Those concerns are outside the scope of this video, but they do deserve societal attention. I've personally become convinced over the past few years that generative AI systems built on deep learning are an extremely impressive technical accomplishment and will have a long-lasting impact on society. There's little doubt in my mind that these models have enormous capability and potential, and that will be very keenly felt in the interactive realm. If you enjoyed this video, please like, subscribe, and press the bell for YouTube notifications. Check out the Patreon at digitalfoundry.net for exclusive and early access content. And to get in touch, just use Twitter. Thanks for watching.